So, because we kind of rushed through it at the end of last semester, last class. That works better. Lecture, Tuesday. Okay, so to start it off with, every time you solve a problem, you want to write down what you're aiming for. Optimism. You're going to get to the goal, write down the goal. So what is our goal for this question? We want micrograms. And we will see as we progressively move further through the semester that micrograms is not going to be a sufficient enough unit here. We should actually say micrograms of, was it aspirin? Of aspirin. Okay. That would be our complete and full unit. Okay. At this stage, not that big of a deal, but watch out for it. Try and use your full unit. What did we start with? Way to shout it out all at once. We started with milligrams, and we had 325 milligrams. Okay. So now the very first test is check. Is milligrams the same as micrograms? No. So we have to do some kind of conversion. In the ideal situation, I would put milligrams in the denominator because I want it to cross out with the milligrams that I've already specified in here. And I would put micrograms in the numerator. Why? That's what we want in the answer. I want micrograms in the numerator. Some of you may have that conversion factor already memorized or dealt with. This argument is not for you. Okay. Those of you that don't have that memorized, we're now stuck. Okay. We don't have the conversion factor here, so we can't put numbers into our conversion. So we now have to decide which unit do we want to keep. Do we want to keep the microgram or do we want to keep the milligram in our next step? What was that? Okay. Last time we wanted to keep the milligram. This time let's keep the microgram because maybe I was wrong last time and it does make a difference. It doesn't.
Your M's are the same.
So the M's should look the same, so let's address that real quickly. We've got an M, and then we have a mu for our micro. They are both technically M's. One's a Greek M and one's an English M. Isn't that fun? Yeah.
Wait, which one is which then?
This one is our mu for micro.
And that's on the top?
That is currently on top in our conversion factor. So let's go ahead and change the color so we know. Our conversion factor we'll call green. That is our micro. The regular M, or the lowercase m, for lack of a better description, is our milli prefix. Okay. So, microgram. What can I convert micrograms to? Grams. Okay, so what I'm going to do is include grams now as my conversion factor. I'm going to try and convert micrograms and grams. So I want this equality, and I'm going to plug in the numbers associated with that conversion. Where do I find that information? Yeah, go for it. What chart? The one in your notes. So if you copy down the chart that I gave you in the PowerPoint slides, you have it in your notes. Or you printed the PowerPoint slides, so you didn't have to write it all down, and you've got it there. Or you've got it in the textbook. You're expected to look that up and reference it. If it is a test, you can't look it up. You can't use your textbook. So where would you find that information? It will be given to you. Okay, either on the very first page of the exam or somewhere in the question. So let's now say what that information would look like. We would see our micrograms. Does that look like a better mu? Okay. Mu equals 10 to the negative 6. So what can we do with that information now? My power of 10 always goes in front of my gram unit, or my base core unit, stick with core. We got our 10 to the negative 6. What shows up in front of the microgram? 1. The reason why most people don't like this initial setup for our calculation comes from now looking at our units. What would our unit be if we did this single calculation? Milligrams, micrograms divided by grams. That is one nasty, ugly looking unit. Okay? So in our very first conversion step, we made things worse. Please, let's hope that in our next conversion, we can simplify things. So we have to bring in another conversion. In that other conversion, what things do I know need to show up? Okay. We need the milligrams to show up. Why? It needs to cancel out, so it doesn't show up in the answer. My milligram has already shown up where? I'll kind of accept the beginning, I'll accept the top more importantly, or the numerator, which means in this next conversion, where does the milli need to show up? In the denominator. Okay. I need to convert that milligram to something, so it could just be a random, what can I convert it to? But we've got more information in the question that would help us decide what unit we want to convert it to. Why do we want to go to grams? The grams need to cancel earlier on in our equation. So if we track through, our milligrams would cancel with our milligrams, our grams cancels with our grams, and we'd have for a unit micrograms, which is exactly what we want for our final answer. So before we can enter anything into the calculator, we need to know what numbers to put into this next conversion factor. How do you know the numbers to put in here? Not the chart anymore. You are required to memorize what milli means. Okay? If you haven't memorized it yet, fair game. Go to the chart. Okay? Milli is 10 to the negative 3. Our power of 10 needs to show up where? In front of the core unit. Which is the core unit? Grams or milligrams? Grams. Here's our power of 10. What shows up in front of the milli? 1. We can now punch it into the calculator and we would get an answer. Questions about that setup? Those are going, that was tedious and painful. Yes. You still got to do it. All right. So, those of you that don't want to deal with your calculator, I don't blame you because your calculator can get in the way with certain calculations. We talked about some shortcuts about what different signs meant and where to do things. So let's take advantage of that shortcut. I would go through and now, excuse me, ignore all of my units because I've already dealt with the units. Now it's just down to numbers. So I'm going to take 325, simplify this out, 10 to the negative 6, and 10 to the negative 3. Okay. I've got some numbers in the numerator and some numbers in the denominator. If the numbers in the denominator were all 1, it's easy. I can just kind of ignore the denominator and move on. Unfortunately, that's not the case. I have a 10 to the negative 6 in the denominator. What did the negative mean? Do the calculation in the opposite location. Where is the calculation being done currently? In the denominator. So let's do that calculation in the numerator. I could very well do the same thing to the 10 to the minus 3, okay, and drop that calculation into the denominator. But what I'm trying to do is get all of my calculations into one side, numerator or denominator. It is easier to work with things in the numerator, so what I'm trying to do is get all of my numbers up into the numerator. I've now done that, which means I can ignore my entire denominator, which means my calculation, instead of being a multiplication, a division, and a multiplication, is now all multiplications. This means I had to be careful with what that negative meant and made sure to get rid of it when I did that swap. The next step that I would manipulate, this is the same as saying 10 to the 6th minus 3. Which then becomes 325 times 10 to the 3rd. Okay. Now I've got something I could work with. What's the issue with writing 325 times 10 to the third?
It's not simplest, or science, or whatever you want to say.
Not scientific
The other one.
notation. In a multiple choice exam, more than likely, your answers are going to be shown in scientific notation. We'll come back to that sig fig question in a second. Okay? So if I'm now going to be comparing to those answers listed, I might want to convert this into scientific notation. How do I do that? It becomes 3.25 times 10 to the 5th. And micrograms. Okay, I now have my answer. Does it make sense that I'm getting a lot bigger of a number than what I started with? Yeah, micrograms are smaller than milligrams, which means I'm going to need a whole lot more micrograms to fill up the volume of a milligram. So it makes sense to be getting bigger. That rough makes sense question is very often skipped by most students. Okay? It does require a conceptual understanding of the size, which comes from practice and skill with manipulating these numerical values. If you've done the practice and have that skill, you can do the approximation and say, yeah, that's about what I should be expecting. If you got a -5 there, your approximative skill should immediately look at it and go, whoa, that doesn't make sense. Which then means what? You don't trust your answer. On a test, what should you do the instant you reach a point where you don't trust your answer?
Check your work.
Skip it, move on to the next question. Okay? You have already spent time on that question. You made a mistake. If you continue to look at that, all you're going to do is continue to make that mistake. Move on to the next question. You've got some work written down. If you have time, you can come back and evaluate that work. Okay? But you should move on. Okay? The idea of moving on is to clear your head of the mess that you made out of the question. Fair enough, it happens. Once your head is clear, you can come back and you're more likely to find the mistake. Okay? Second time back, what should you do? Do not look at your work, because your work already puts you in a situation where you don't trust your answer. So don't look at it. Solve the question again. Do you get the exact same answer?
Hopefully not.
If yes, your gut is either wrong or you really don't know what's going on, you might as well just guess anyway. Okay? If you get a different answer, now you're kind of screwed because you've done the question twice and gotten two different answers. This is again a time to take a break, move on to something else, come back and see if you can rationalize why you got two different answers. If you attempt it a third time and you still get a different answer, literally just guess. Okay? With that in mind, before you literally just guess with any test I give you, you need to read the directions. I will leave it at that. Has anybody looked at the practice exam yet? Anybody catching my drift on that? So you just got confirmation from a few people in this classroom that said that my statement made sense. If it doesn't make sense to you, you should probably look at the exam and read the directions. Okay? Questions about our format and setting it up? Yes?
Can you go back and repeat the bottom part again, how you got 10 to the 5th power? And you just moved.
I'm moving the decimal place, so I'm making my 325 smaller, but I can't lose that meaning, which means my power of 10 must get bigger. Kind of makes sense? Okay. So is everything metric? So this is the fun thing. A lot of people go, I can do these power of 10 shifts all over the hell and gone, I'm awesome at it. Great. That works if we're in a metric system. Aren't we always in a metric system? No. Okay. Particularly because we're dealing with science, which is a metric system, and we are not outside of the US or the two other countries that use the English system. One of them is not England. Okay. we will have to convert between the English system, or the American system, if you will, and the metric equivalent. Okay? Those conversion factors are really, really obvious. For instance, to switch an inch to centimeters, it is very clearly and obviously 2.54 centimeters in 1 inch. Right? You're all like, duh, didn't everybody know that? Yeah? That a no? Okay. Nobody knows these unless you're freakishly good at converting things. Okay. Some of them you might have picked up from having to do these conversions frequently. Most cases you haven't. Okay. Since you all have varied backgrounds, we cannot make the assumption that you know them from outside of the class. So the only way we can test on them is do two things. Number one, tell you, memorize them now. Or two, that's dumb, don't waste your memory, I'll give it to you. Which would you guys like me to do? The second one. Good choice. That's what I agree with too. Okay? So if I'm expecting you to do an English to metric conversion, I will give you that information. Okay? And that information will get presented like it is written here. In an equation format, not in a conversion factor setup. We'll have 1 inch equals 2.54 centimeters. It is your job to interpret that equation into the proper conversion factor. Make sense? Okay. You had a question about sig figs on that last one. Okay. We went through and did that bottom one. Let's just jump to our answer. We had 3.25 times 10 to the 5th micrograms. And you mentioned sig figs. Okay. How many sig figs should I be reporting my answer to?
3.
How do you know it's 3?
305 is the least amount.
You look at the information given to you in the question. The information given gave you 3 sig figs. Okay. But wasn't one of the conversion factors we used? Oh, crap. I don't remember what it was. Which way did we have it? We had it this way, I think, didn't we?
Yes.
How many sig figs in that conversion factor? So I see a 1.
2.
I hear a 2. Do I hear more?
8.
8. It's actually a sideways 8. Why is it infinite? It's an exact measurement, an exact comparison. That is the definition. It is 10 to the negative 6 grams in exactly 1 microgram. Because it is exact, how many sig figs? Infinite. So that will not affect the sig figs in my answer. The other conversion we had was the milligram to gram. How many sig figs in that one? Infinite. So what's going to determine our sig figs? Our 325 milligrams, which was how many sig figs? 3. When we get down to our final answer, we have to have 3 sig figs. Is it written with 3 sig figs?
Yes.
Yes. Our answer is correct. So every time we do a calculation, we have to be watching out for those sig figs. Why does that become irritating when we move through and look at our metric system? Okay. How many sig figs in this calculation? 3. Okay, that's interesting. You're saying the 454 is your 3 sig figs, right? Why not the 1? There's an interesting question. It's not an exact measurement. But what we are saying is that by definition, 1 pound exactly, is approximately 454 grams. Okay, so we are defining the 1 to be an exact. The 454 is our measurement. Okay. Oh, and our internet is being very flaky today. Okay, the other option, 1 quart, 946 milliliters. How many sig figs? 3, because 946. Okay.
Is that what you're saying, why? Because it's measured?
These are measured-ish values, yeah. And we have to do a measured-ish value because we're comparing 2 different unit systems. Okay. So the last one on this, You know, just to bang the point home, how many sig figs?
Infinite.
Why infinite?
Because it's an exact measurement.
How do you know it's an exact measurement?
Because it's a conversion.
What does that little tiny footnote say?
That's exact.
The 1 inch to centimeters is defined as 2.54. As soon as it is defined, it is now exact. Isn't that lovely? Okay. How would you know that? You're told that. Okay. The English to metric conversion system, in fact, any conversion system outside of the defined system is problematic. Trying to bring any two conversions near each other that aren't in the same system is awful. And you will run into this issue every single time. Why did they only give you 3 sig figs for the other 3 conversions? Good point. Run with that. What do you mean it's not awful?
I don't want to deal with more numbers than 3.
The chemists or the whoever you want to say wrote this book doesn't like sig figs just as much as you do. And they don't want to have to think about how many sig figs they're running through their own calculations. So they have decided, for their sake, that they are going to use 3 sig figs pretty much wherever they can. Which means when they go through to write an answer to a calculation, they know that they need to report to 3 sig figs, and they no longer have to worry about it. Okay? This is why sig figs are particularly annoying, because depending on who you talk to, where you're in the chapter you're at, you will find conflicting arguments on how to deal with sig figs. Okay? Welcome to science. Okay? And if you thought we couldn't agree on that, there's tons more that we can't agree on as well. So you have to be careful when approaching these. This is the first section where it's going to become super, super important. Be aware of that when you go through to calculate. If it comes down to it on a test and you come out with an answer and you see 2 possible answers and you think it's a sig fig issue, raise your hand and be like, dude, really? Is that what you're going to do to me? I'll be like, sorry, that's what I was intending to do. Or I'll be like, oh, crap, no, that's not what I meant to do. Let me eliminate one of those answers. Okay. This is the first test and pretty much only test that you really have to watch out for it. Okay. That said, every time we do a question in here, we'll come back to that sig fig question. So, length of an American football field, including the end zones, is 120 yards. What is the length in centimeters? Okay. So here's our question. We got a bunch of conversion factors listed through here. What I want you to go through and do is set this up. Do whatever you got to do to set up that conversion. If you think you can do it in your head, I'm fine with that too. Crank it out. I want to know the final correct answer for this. Okay. And if you got questions, raise your hand. I'll come to you. Okay. Well, this is bizarre. Okay. Just entering stuff into the calculator, both of these answers have valid methodology behind them. They are still both technically wrong. What is the technicality? Significant digits. How many significant digits are you allowed to carry through in your calculation?
3.
Who said that?
120. So it's
No, because
Why did you say 2?
0 is not significant.
If we look at the number we're starting with 1, 2, 0. The 1 is significant, the 2 is significant. Is the 0 significant?
No.
No, because
No
you
decimal.
need to have the decimal for that 0 to become significant, which means we're only allowed 2 sig figs in our answer, which I guess still technically meant you were wrong. Our answer comes out to be 3 zeros? Centimeters. Okay. And we'll still come through.
Can you explain
We're still going to come back to it, yeah. We're going to walk all the way through it. I just want to touch base on what's going on with it.
So I used like the 2.54
We're-
centimeters. I thought you said if it didn't exact things, infinite.
So we'll address that. We'll address that, I promise. Okay, so let's go through and look at our calculation beginning to end. Where do we start? What do we start? Every question. What do we want to end with? What do we start with? 120 yards. Okay. So ideally, we set this up. Our very next conversion here, what do we want? We want yards to be gotten rid of, and we want, what do we want? What's our ideal system? Ideally, we want centimeters. Do you really want to do 6 steps?
Yes.
You really want to get this done as fast as possible. So we would ideally get yards to centimeters. Do we have that conversion? No. So now we're stuck in trying to decide what we want to work with. Which do you want to work with, centimeters or yards? Yards. Okay. What can you convert yards to? Or, never mind. Yeah, or feet. Okay. Depending on which direction you go, be it yards to meters or yards to feet, you end up with the 10972 number, or you end up with the 10968 number. Okay. There were 2 possible paths in which you could do this conversion. Did you end up with the exact same answer at the end? No. Why? You're doing multiple English metric conversions, and they aren't exact measurements. Because they aren't exact, as soon as you diverge in your path, you will get slightly different answers. Which is awesome when it comes to writing a multiple choice test. Because I have to predict all of the correct paths and make sure that the answer I report at the end doesn't come out with a rounding error different from if you went a different path. It's awesome. Okay? So this is an issue I'm aware of, and I try and check for it and prevent it from showing up on the exams. That does not mean it doesn't show up in, say, online homework systems. Good thing we don't use that, because I've seen it in the online homework system, and it is exceedingly frustrating. So let's pick. What are we going to switch the yard to? I think I heard more feet than meters. Sorry, we're going to stick with the feet.
Why not?
Okay. So, how do we convert yards and feet? 1 yard is 3 feet. So I heard a lot of 1 to 3s. Okay, 1 to 3.
Nope, the other way.
Okay.
1 on the denominator.
How do we know?
Because 1 yard equals 3 feet.
What number shows up in front of yards in our equality? What number should show up in front of yards in our conversion factor? Use your equality to tell you where the numbers belong. That's why they're there. What unit are we now in? Feet. So, is feet our final answer? No. So, feet needs to show up minimally on the bottom because I want to get rid of it. Ideally, what do I see on top? Ideally, centimeters. We don't have that conversion. So, we'll switch it to inches. Do we have the conversion between feet and inches?
Yes.
What is that conversion?
1 foot, 12 inches.
What number shows up in front of feet?
1.
In front of inches? Wow, this is the most unison I've ever heard a class. Do you guys practice?
We just want the answer ready.
Inches. We need to get rid of inches, and what do we want? Do we have a conversion between those? Yes. Pull using information found up in the top. We know that 1 inch is 2.54 centimeters. Okay. And it is an exact measurement. I'm sure somebody went through and calculated it. Which number did this one come out with? This was the 10972.8. Okay. Address our sig figs. There were lots of questions on what's going on with our sig figs. So, what we need to do to decide our sig figs and our answer is to look at the sig figs at every step of our calculation. I'm going to show the sig figs in purple because we don't have that. How many sig figs in our first value? 2. The next one.
Infinite.
Infinite. Okay. That is within the English system. 1 yard is defined as 3 feet. The next one. The next one. What's going to determine the sig figs in my answer? The very first one, the least amount, because I'm doing multiplication and division. So this goes all the way back to that slide where we have all of our rules outlined, which means my final answer needs to get reported to 2 significant digits. I will underline those now. Okay. I now need to address rounding if it's necessary. I will look at my first insignificant number and say what? I need to round up. So I will add 1 to the previous digit, and I end up with 11. But I need those zeros. Okay. And it must be reported to 2 sig figs. Is it now reported to 2 sig figs? Yes. Okay. Could I have written it a different way?
Yes.
What is that different way?
1.1 times 10.
1.1 times 10 to the 1, 2, 3, 4. Not that I didn't trust you. And we have our final answer. So, Katie, does that answer your sig fig question? Okay. Other questions?
You have to convert it to the other thing, or can you read it in the first?
Which answer is the correct answer? I believe is what you're asking.
Yeah.
Which answer is correct? Both. How do you know which answer you should provide?
You'll tell us.
If it's multiple choice, all your answers are in scientific notation. You should answer your scientific notation one. If it's multiple choice and none of the answers are in scientific notation, you should answer the bottom one. If it is a straight up show your work, both are correct. I can't take off points if you give me the correct answer but not in scientific notation. Unless I ask specifically for scientific notation. Okay? Nasty. Questions about that? We got a chorus of we're tired of this, so let's see if we can move on. Okay? So, can you do this conversion straightforward? One of my favorite little examples. Harry has 100 pennies, Douglas has $3 bills, Sally has 30 dimes. Harry wants to exchange his pennies for dollars. Douglas is infatuated with silver things, and so will only exchange his dollar bills for silver objects. What does Harry have to do to get his pennies converted to dollar bills, and how many dollar bills can he get? So number one, we're going to slide down to a little side note down there. You've seen these kind of questions before, right? Seen them in your math questions? Train X leaves slide Y. What time does the train encounter the bicyclist going the opposite direction to Chicago? Okay. Why do we have these stupid word problems? We have these stupid word problems not so that we try to make you struggle and go through and solve them, but to come up with a standardized notation. It is the notation on how you solve that question that you need to build and work from. Because it is that notation that when we change the units to things that make absolutely no sense, you still have the ability to solve the question. Okay? That is why we have these problems. Should we go through and try and solve this one?
Yes.
Do I need to read it out loud?
Yeah.
Yep.
Let's see if I can do it. Harry has 100 Snorlaxi. Douglas has 3 Skittle Farts. Sally has 30 dimes. Harry wants to exchange his Snorlaxi for Skittle Farts. Douglas is infatuated with silver things, and so will only exchange his Skittle Farts for silver objects. What does Harry have to do to get his Snorlaxi converted to Skittle Farts, and how many Skittle Farts can he get?
I put a lot of skill parts in there for, like, on purpose.
I think when I initially wrote it, I was trying to convince that somebody else in the class would have to read it. So I'd start with the first one and be like, okay, I need someone to read the question to me, and as soon as someone started, I'd do this. It's kind of backfired. Okay, so let's set it up. What do we have to do? What do we want for a final answer? We need Skittle Farts. And because I don't want to write out Skittle Farts the whole time, I'm going to come up with an abbreviation. We'll call them. Okay, I'm fine with that. SK. I would have gone with SF, but you know.
We change it?
I'd have gone with
Okay. So, what are we starting with? It's a harder X. Snorlax. So we'll call it SX. How many SX do we start with?
100.
I actually didn't remember. We have 100 of our Snorlaxi. We need to convert these to Skittle farts. How do we do it? Ideally, we would go SX to SK. We don't have that ability to do that conversion. Okay? We have to process this on where we can go with our paths, which means we can now choose which unit we want to convert. Which unit do we want to keep? SKs or SX? SX tends to be the standard because that helps us simplify our units. Immediately we can cancel. What can we convert the SX to?
Eight times.
Dimes. How do we know we can convert it to dimes? The conversion factor is given to you in the upper right-hand corner, conveniently up in the black area where you can't read it. Okay? So we can convert to dimes. What is our conversion factor? 8 dimes, 10 Snorlaxi. And this way, if you have those 3D glasses, they'll jump out at you. Thank you. Thank you. I appreciate the laughter. What unit am I now in? Dimes. Do I want dimes in my final answer? No. So what do I have to do? It needs to be in the denominator so that it can cancel. What do I want to convert to? Skittle farts, labeled as SK. Do I have a conversion factor between dimes and Skittle farts?
What did we,
One what?
skill fart?
One Skittle fart is 3 dimes. What is my unit now? Skittle farts. Now I can punch it into my calculator and I end up with my answer. I didn't even hear what you said, so it's okay. Taste the rainbow? Questions in that approach? Okay, this is what we're working on. We want the notation. The numbers are ultimately meaningless. You need the notation to be able to solve. That is all you need to get out of this chapter. Okay? The rest of the chapter, we then start to go through and look at varying other measurements. Okay? So let's look at some compound units. What are the units for the speed of your car, bike, or a brisk walk to class? Are they all the same unit?
No.
Okay. Probably not. I mean, depending on how fast you bike, drive, or walk, you may adjust your measurements. Okay. Well, what's a unit that you might use? Miles per hour. Okay, that's a reasonable unit. Why is my question not popping up? So let's take a look at a motorcycle traveling at 105 kilometers per hour. Can you convert that to the speed in meters per second? How would you convert it to meters per second?
1,000 meters per 60 seconds.
Nope. Meters per second. What do we start with?
Kilometers per hour.
Do our units match? No. So we need to fix our units. How do we fix our units? Pick one. I don't care which one. Pick one. You picked hours. I like it. Let's get those hours into seconds. So we'll pick hours and we'll put it on top. Why put it on top? So it cancels with our hours on the bottom in the other case. I want to convert that ideally to seconds. Okay? I heard a 60 seconds, so let's go through and write that out. 60 seconds is 1 hour. Not quite. We don't have a direct conversion from hours to seconds. Okay? And don't give me that nonsense of multiplying that crap in your head. Okay? What can we convert hours to?
Minutes.
Minutes. Couldn't you also convert to days?
Yeah, but you wouldn't want to.
Why not?
Because you get further away.
it gets further away from your target. So every time you're starting to do your unit conversions, you will find you have multiple different directions you could go within your conversion. You get to decide where to go. What if we'd written days? And our very next step, we try and get rid of days, and we'd be like, well, crap, I have no way to get rid of days. What does that mean?
You have to convert it back.
You have to convert it back. It's not wrong, you just end up undoing the conversion you've already done. So let's go hours to minutes. How many minutes are in 1 hour?
60.
60. What are my units now? Kilometers per minute. Can't just disappear that kilometers. I want kilometers per second. What do I want to convert to now? Meters per second. Fair enough. Thank you. So we're continuing on our time bend. That's fine. We want to get rid of minutes, and we want them to become seconds. Do we have that conversion? That was our 60 seconds is 1 minute. What unit do we now have? Kilometers per second. We want meters per second. We're still not there. What's our next conversion? Kilometers into meters would be our ideal conversion. Where should the kilometers show up?
Denominator.
In the denominator, so that it cancels, and I want meters to show up top. That is my ideal circumstance. Please say I don't have to do any more conversions. Do I know a conversion between kilometers and meters? I know kilo is 10 to the negative 3. My power of 10 affects the base or core unit, and the reason why we're going to dodge base unit as a reference is base makes you think bottom. We're not talking about the bottom. We're talking about our core unit, which is meters. Not negative 3, 10 to the third.
Yeah.
You can shout out. I'm wrong. It's fine. I'm not that terribly offended. Now when we track our units, what happens? We get meters per second. We've now done our conversion. Magically, the book presents this as a brand new, oh my God, it's a whole new problem. It's the exact same problem we just solved with the micrograms to milligrams. There is no difference. All we are doing is converting units. Nothing new. How far did the bike get in 120 seconds? Set up the work, solve. If you got questions, raise your hand. You're given 105 kilometers per hour and, where did it go? And 120 seconds. You can start your calculation with either of these. You will get the exact same answer. Okay. So now the question becomes, which do we want to start with? Okay. Some people like to start with 120 seconds. I would make the argument that it actually makes sense to start with the 105 kilometers per hour. Why? What's the answer I'm aiming for? Kilometers. Does kilometers as a unit show up in 120 seconds?
No.
No. Where does kilometers show up as a unit? In the 105 kilometers per hour. So I'm going to start with the 105 kilometers per hour and theoretically be able to squeeze this calculation in here. Where do I want the kilometers to show up? In the numerator. So I will write my kilometers here and my hours on the bottom. What number shows up in front of kilometers? 105. Why not put the 105 on the bottom?
There's not 105 hours in a kilometer.
It's a good way of looking at it. The 105 is immediately followed by what unit? Kilometers. Which means when we go to our conversion, where should the 105 be immediately followed by? Kilometers. So if I put the kilometers in the numerator, and it better have the 105 directly in front of it. Okay? So now I can compare across at my answers. I have kilometers in the numerator and kilometers in the numerator. Awesome. But what am I starting with? Hours in the denominator. I need to get rid of that unit. Okay? So I already know that I need to do what? I need to put hours on top as a unit. Okay? Now we run into the question of where we get that number. Okay. This is where you could split off and say, well, I can convert 120 seconds into hours and then plug that number in. That is perfectly valid. You are now doing 2 calculations instead of 1. So let's string it together as one calculation. What can I convert hours to?
Minutes.
What is that conversion? 1 hour is 60 minutes. What are my units now?
Minutes.
No.
Kilometers a minute.
Kilometers per minute. Okay, I need to get rid of minutes. So in my very next step, what do I want to do?
Minutes over
Minutes in the numerator.
Could you do 2 minutes over 120 seconds?
We'll address that in just a second. Okay. I don't have minutes as a number. I have seconds. Can I convert minutes to seconds? What is that conversion?
1 minute.
1 minute, 60 seconds. What is my unit now?
Kilometers.
Kilometers per second. I need to get rid of seconds. Do I have seconds? I know I have 120 seconds. Over what? Over 1. Why 1?
So we'll change the value.
If it's any other number than 1, it's not 120.
But how did it get from the denominator to the numerator?
How did what get from the denominator to the numerator?
If the reciprocal is the same value.
No, it's not. 120 seconds is found where? Numerator or the denominator? Numerator. All I'm doing by dividing by 1 is accenting the fact that 120 seconds is in the numerator. If I make that 1 any other number, it's no longer 120, in which case it doesn't match the information given. Should I put a different unit underneath it? No, because then
You get rid of seconds.
I change the meaning of 120 seconds. They become 120 seconds per some other unit. So all I'm trying to do by putting that 1 there is to accent the fact that the 120 seconds is in the numerator.
Oh, because you're going from 1 second to 100. Okay.
When we track our units now, what happens? We would end up with kilometers and we have our answer. Several people asked, back at this stage, let's say we alternate down, can't I just say, I need your help on this.
2 minutes over 120 seconds.
Thank you. 2 minutes over 120 seconds. Yeah. Yeah, you can. That is perfectly valid. But to do that, what did you do? You did a step in your head. You did that step in your head correctly because you already understand how to multiply 1 by 2 and 60 by 2. Great. What happens when you can't do that calculation in your head?
You're screwed.
Put more nicely, you get the answer wrong. So what you need to do is get out of your head. Do not use any calculations in your head. I know you're like, oh, I can totally do my times 2 tables. That's cool. Okay? I really believe you can do your times 2 tables right now. 60 minutes into the exam, with 15 minutes left, your times 2 tables are horrible. You won't be able to do them. Okay? So right now what you need to do is do all of the outline of the work and set up getting out of your head so that when you get to the exam, you're already used to the pattern of doing it out on the paper. Said another way, and I'll keep saying this throughout the semester, your brain is a scary, scary place. Do not do chemistry in your brain. Okay? That is a bad general philosophy thing. Don't do it. Put it on paper. The moment it's on paper, you can evaluate it and you can actually notice when things are correct or when things are wrong. But it is only when it makes it to the paper. Okay. Was working with some students in organic. Same deal. They had this hard time. We were talking through it. Oh, I can't figure it out. And they gave up and they went home. 30 seconds, they wrote it down. They had the answer. After 20 minutes of trying to talk through the question, I kept saying, just write it down. Just write it down. Like, no, I'm not going to write it down. Fine, don't write it down. You're still getting it wrong. Why am I getting it wrong? Because you're saying it out loud. Write it down. The instant it was written down, they had the answer. Write your work down. Do we need to go through and solve the next one?
What
Okay.
was the final on that?
The number? Oh.
3.5 kilometers per second.
No, you crossed out the
Oh,
seconds.
okay.
So I heard 3.5 kilometers. Let's evaluate sig figs and make sure I agree with you. I do agree with you. Why are we at 2 sig figs? 120 only has 2 sig figs. Okay? Which admittedly was completely a mistake. I should have put the decimal in. I wanted 3 sig figs. But.
But if you're starting with 105, would be 3?
So the 105 has 3 sig figs. So if we go through and look at our calculation and crank it all the way through and evaluate our numbers for our sig figs in our calculation. Stupid eraser. First value, how many sig figs? Second value. Good. We're getting a little bit more of a chorus there. Next one. Next number. 2. Based on multiplication division, it's the lowest number. The 2 sig figs dominates our answer, or dominates our information, so we have to use 2 sig figs in our answer. Make sense? Okay, let's clear everything out. Let's see. Oh, man. So I don't even know what this work was supposed to show. Maybe it was that answer. So how long in hours to go 90 miles? What are we solving for?
Hours.
What are we starting with?
Kilometers an hour.
We have a kilometers per hour, yes. What else do we have?
90 miles.
We also have 90 miles. Which of those two do I want to work with first?
Kilometers an hour.
Okay, I heard kilometers per hour, and this is the one I actually want to start with, even though it's a little bit odd in our setup. And that's actually why I want to address it. Where does hours need to show up? In the top.
Oh.
Because, in my answer, where does hours show up? On the top. What am I putting down below? Kilometers. Because I have a conversion factor between kilometers and hour. Where does the 105 show up? I have not heard a correct answer yet. Top and bottom are both wrong. In front of the kilometers. Do not associate numbers with a location, above or bottom. Associate numbers with the unit. If we look at the 105, what is the unit that comes immediately after it? Kilometers, which means when I look to my conversion factor, the 105 must show up in front of kilometers. By saying on the bottom, our previous calculation was then wrong, because the 105 showed up on top in the previous calculation. What number shows up in front of hours? 1.
But that wouldn't change the...
And that 1 will not change the value of the 105. Do not enter it into a calculator. You're not doing a calculation yet. You're making sure that the relationship between hours and kilometers stays the same. Okay. If we make that 1 any other number, that relationship changes. Yes?
Why is hours on top?
Where are hours in our answer?
On top. But then if you like go further,
Okay, let's take it further. See what happens.
hours?
Do we want hours to cancel out? No. So don't touch the hours. They're perfect. They are exactly where they need to be.
But wouldn't it be like an hour? Would that...
Kilometers in the numerator.
It'd be, instead of being kilometers an hour, it'd be...
Hours per kilometer?
Per mile.
Yep.
Wouldn't it's the same value then?
Yep. It is exactly the same value, believe it or not. Is our unit in our left side equal to the unit on our right side? What's the issue? We have kilometers, so what do we need to do? I want kilometers in the numerator. I know you're jumping ahead. You're getting itchy on this. What do I want to convert kilometers to? Miles. Why miles?
Because it's 90 miles.
Because I have some more information about miles that I could potentially cancel it. What is the conversion between kilometers and miles?
1 mile for
1 mile is 1.61 kilometers. What is my unit now?
miles.
Nope. Hours over miles.
So we need...
I need to get rid of the miles. What do I need to do?
90 miles in the numerator.
90 miles in the numerator over 1. What happens with the units? Cancel out, and I'd be left with hours. How many sig figs?
3.
3. 3. This is one of those nasty ones. And that one is 2. So I end up with 2 sig figs in my final answer.
I'm curious about that.
Go ahead.
Okay, so earlier I heard you mention that with the 3 sig figs that are in centimeters, because that is actually like proven,
Defined.
we use that. But is like, I mean, 1 minute and 60 seconds in a minute is valid, isn't it?
That 60 seconds in a minute is an exact value. So that's another infinite one.
Okay, good. So in that 60 minutes, as long as there's no decimal, would just be 1 sig fig?
Infinite. 60 minutes is exactly 1 hour.
I'm sorry.
Yeah, that's how you got
How are we doing?
this part. This
2 sig figs, yeah.
Okay, wait.
Questions? You guys seem really excited about this.
So when you round the answer,
Is
it's
infinite.
1.40.
Sig figs.
So there's a question here about what the actual number is, because I think we have a rounding issue popping up. So your calculator number is 1.38. We said only 2 sig figs. We underline our 2 sig figs.
1.4.
Forgot the unit. 8 is our first insignificant digit, is larger than 5. I must add 1 to the previous. My answer, that's a 1, becomes 1.4 hours. We got it? Ish? Yeah. I like the defeated yeah. Skip all that. Oh, my least favorite topic. Oh, I stopped recording. Percents. We'll end on percents for today just because I don't like dealing with it. Percents is ultimately just another conversion factor, allowing you to relate one quantity or one part of a sample to the overall sample. We still got 5 minutes, right? 2:15? Yeah, okay, I'm just checking. Okay. Part of our sample to the whole sample, also known as grades. It's also a conversion factor. I mean, it's the same thing. And what you are looking at is pretty much the ability to calculate your grade with percents. One of the things that becomes kind of weird with our percents is that they are unitless, which means the bulk unit that we are using, our measurement, must be the same. So if I'm going to go through and look at my one quantity, say 1 gram, okay, of X over 2 milliliters of Y, are the units the same? Those are 2 different measurement systems. I cannot calculate a percent that way within the context of this class. Okay. To calculate the percent properly, I need to make sure that we are looking at mass. Okay, so let's make it 2 kilograms of Y. Old mass still doesn't count. That measurement unit must cancel. For it to count, I have to be grams of X over grams of Y, or grams of the total sample. Okay? Our measurement unit must be the same when we calculate a percent. Okay? All we're trying to do is now relate this to an easily measurable system, and that's where the 100 comes in. Because if we just took, say, that 1 gram out of 2 grams, we would end up with what? 0.5. Y'all love decimals, right? So we'll just keep everything in a decimal format. Okay? Most people don't like decimals. So what do we end up doing? We multiply it by 100 parts. When I multiply 0.5 by 100, I end up with 50%, meaning 50 out of 100. What is 50 out of 100? 0.5. There's our fraction again. That's what that percent means. It's out of 100. Okay. The 100 happens to be a more round, easier number to work with, and that's the one we stick with. So if I had a sample of bronze, that had 79.2 grams of copper and that number of tin, what is the percent copper in the bronze? So, percent copper. How do I calculate the percent copper? What should be on top? Grams. I don't care about the units or the numbers. Oof, that was a bad thing to say. Okay, I want the units. Grams.
79.2 over 10.
That's a number.
Over grams.
But it says percent copper. So grams of water over grams of the ocean. Does that make sense? No. Answer the question that's asked. It's percent copper. So the unit is grams of copper. Okay. For those of you that didn't learn this yet, copper symbol is Cu. Remember that. Grams of copper in what?
Over grams of tin.
Nope.
What are you looking for?
We're looking for the percent copper in bronze. So the number on the bottom had better be the mass of the bronze. What is the mass of copper? 79.2. What is the mass of the bronze?
Grams.
It didn't actually come out to 100, did it? I think it was 90. I really can't do math right now. Yeah, I'm going to say it's 90. Should I write it like that? Why no? Why 90.0? Yes. Why? Sig figs. We have to track our sig figs through it. Okay, we just did an addition. We have to keep track of our sig figs. Okay. When we now go through to enter it into our calculator, we'd end up with a fraction. Remember, we're in percents. We don't want a fraction, so what do we have to do? You have to multiply by that 100, and we now have the percent copper in our sample, which I believe comes out at 88%. And you would be wrong. Why?
Because you need the point zero.
Why do we need the point zero?
This is the sig.
3 sig figs. For that reference to 90, in totaling that, you are right when we add 79.2 plus 10.8. Remember how those decimal points disappear? We enter that in the calculator gives you exactly 90. The calculator does not understand sig figs. When we add and subtract, we have to report to our least precise place. Our least precise place with addition and subtraction is, in this case, the 10th place, which means I must report that at 90.0, which then means I have 3 sig figs. Sorry, we're done. I'm apologizing for continuing too long, not for saying we're done.